cars are becoming more and more efficient and accessible. They're becoming more and more popular in the US. Not only are they a popular mode of transportation, but they're becoming a popular idea. They're being seen as the future. They're becoming the answer. Are these claims accurate? Could we have found the future? Could we have discovered the answer? Before we know what the answer could be, we must first define the problem. The problem generally cited in the context of electric vehicles is the climate crisis. The climate crisis, also known as global warming or climate change, has become the ethical motivation for a full switch to electric vehicles. Over the past 50 years or so, the Earth has gotten warmer by 1.2 degrees Celsius, and everyone agrees that pollution, including land, air, and water, is not at all beneficial to our environment or the people inhabiting it. So now we're faced with the question, will EVs prevent pollution and save us from its effects? It is expected that electric vehicles will have the most effect in reducing air pollution due to the fact that they have no emissions. But upon closer inspection, there's much more going on than meets the eye with electric vehicles. There's no completely green way to operate our country, thus the issue must be looked at more of a standpoint of the lesser of two evils. The evils of the internal combustion car are very well known and focused on in terms of pollution. Internal combustion cars and electric cars are very similar in many ways. They've got similar bodies, similar tires, similar frames. They're actually quite similar, other than their engine and power supply. While that might seem like a minute difference, it is the difference that tips the scales. What hidden evils do electric cars hold? Will electric vehicles really prevent pollution and other related environmental issues? And would a full switch to electric cars be the answer? A full switch to electric cars would be harmful for three main reasons: the mining of the resources, the powering of the vehicle, and the recycling of the battery. Let's start off with mining. Many hidden evils are already present in electric vehicles before the rubber even hits the road. The putting together of the individual parts of an electric vehicle is not in and of itself more harmful than the putting together of any other machine. Where the problem lies is in the mining of the resources for the battery of the electric car. Electric cars run off of a lithium-ion battery, which is made up of lithium, nickel, graphite, cobalt, among other elements. The mining for these elements is often difficult and underdeveloped, and very destructive not only to the environment, but to human rights and all of the people involved. Let's start with the mining of lithium. Lithium has already doubled in its production in the past few years and is on a trajectory to double again and again and again in coming decades. With current trajectories, many mining companies are scrambling to get ahead in the race to make their fortune. Lithium is the main component in a lithium-ion battery and is a toxic and unpredictable metal. When refined, it bursts into flames with contact with water. What makes it so efficient for batteries is that a single particle of lithium will readily shed an electron that will zip back and forth between the positive and negative terminals of a battery, storing and discharging power as it goes. Lithium is mined from brown, briny saltwater deposits underneath the surface of an area called the Lithium Triangle, which is in the vast salt flats of South America and ranges from Argentina to Chile to Bolivia. Miners extract this briny groundwater and put it into massive evaporation fields. Tons and tons of water is mixed into these evaporation fields that take about a year to complete. The vast salt flats of South America are one of the driest, most arid places on Earth. Thus, taking the groundwater depletes all of the natural resources. But groundwater isn't the only problem. Toxic chemicals such as hydrochloric acid are mixed into the evaporation fields to help the extraction process. These fields are so big that they are visible from space. These chemicals oftentimes leak into the local groundwater supply and poison the groundwater for all of the local plants, animals, and people. North America also has lithium mines. Research shows that North America contains possibly the largest lithium mine and the lithium reserve in the world, known as Thacker Pass. Thacker Pass is located on the Nevada and Oregon border and is estimated to contain between 20 to 40 million tons of lithium. The largest reserve in Bolivia contains 21 million tons. To extract 20 million tons of lithium would require the amount of water used to fill Arizona with water the depth of an Olympic swimming pool. NASA researchers, using satellite signals to accurately depict the drop in groundwater levels that will be caused by this mining, are worried that the groundwater will drop to dangerous lows. This site is also located on a dormant volcano on an Indian reserve and is referred to as sacred land by the inhabitants who live there. But despite all this, the Supreme Court ruled in favor of the mining company, and the mining is estimated to begin in around 2026. Despite the protest of local ranchers, Native Americans, and other civilians. Like in South America, the groundwater will be poisoned, but this time it will be US citizens being poisoned. Not only that, but an entire tribe of people will become homeless. Next is nickel. Most nickel is mined in Russia, and most nickel mined in Russia is mined in one city 180 miles north of the Arctic Circle called Norilsk. Nickel mining is similar to most other conventional mining. The only difference is the amount of sulfur dioxide it produces. The amount of sulfur dioxide that can be safely breathed by a human is 9.4 parts per million. Norilsk at times exceeds this threshold by 40 times. In the year 2015, Norilsk was reported to have emitted 1,883,000 tons of air pollution of sulfur dioxide. Finland often accuses Norilsk of sending death clouds over the border, and due to complaints, Norilsk shut down its biggest nickel factory. A few days later, the Dalkadon River turned blood red for unknown reasons, and a few months later, the other nickel mines had picked up where the main nickel mine had left off. Adding to the stress of nickel mining will not only worsen the state of Norilsk, but will cause other cities like this to appear not only in Russia, but around the world. If you think nickel mining and lithium mining is bad, you better buckle up for cobalt mining. Cobalt mining is expected to reach 220,000 tons by next year, which is triple its production in 2010. Over 60% of cobalt is found in the Democratic Republic of Congo. The DRC, hence the DRC is where most of the cobalt mines are. The DRC routinely violates human rights, however. Consistent with that, the DRC is home to some of the most horrific worker treatment, worker abuse, and worker pay. An average able-bodied adult worker makes about $1,200 per year. There are only two options for the impoverished majority in the DRC, either to work for the cobalt mines or to starve in the jungle. Cobalt mines essentially come in, take land, evict the inhabitants, and force them either to work for them or go starve in the jungle. There's no third option. Also, cobalt dust happens to be toxic to breathe. But in the DRC, there are no regulations in these mines. The work continues. Men, women, and even children are forced to breathe in this toxic dust every day. Mercenaries make full-time jobs out of stealing children and trafficking them to these mines where they work handling raw ore. These children rarely ever survive to adulthood due to malnutrition and the toxic effects of cobalt. This is the equivalent to modern-day slavery. There's no silver lining to the electric vehicle mining. Statistics here are based on only 1% of the vehicles on the road being electric, meaning that to get a full view of what a full switch to electric cars would really be, you'd have to multiply everything I've said so far by 100. The mining of the resources for the lithium-ion batteries is not only harmful to the environment, but to entire populations of people. But now that the electric car is built, what do we do with it? Electricity, or energy, cannot be created or destroyed. It can only be transferred from one form to another. Albert Einstein. There's a common misperception that electric vehicles run completely clean. They emit no emissions, right? Simple as that. Well, not quite. Electricity doesn't just make itself, and electric cars can't just run off magic. Electricity is oftentimes not environmentally friendly either. 1 kilowatt hour is the amount of electricity needed to power 1,000 watt appliance for 1 hour. An electric vehicle battery holds about 100 kilowatt hours, which is the equivalent to running a TV for 1,000 hours straight. The average American driver drives 1,200 miles per month, and an electric vehicle battery consumes about 34 kilowatt hours per 100 miles, making the amount of electricity used per month 408 kilowatt hours. But since the average household owns 2+ cars, this number would be closer to 816. America produces 4.23 trillion kilowatt hours, 1.6 of which is used residentially. The average American uses 890 kilowatt hours in a household. Therefore, adding the stress of electric vehicles would multiply this number by 2, meaning that the amount of electricity used residentially would need to be multiplied by 2, making this America's electricity grid needing to expand by 38%. But since 2000, America's power grid has only grown 8%, 0.3% per year. In order to get the needed 38% in a period of 20 years, America would have to multiply its growth by 5 times per year. But a breakdown of electricity directly impacts an electric vehicle's positive impact on the environment. In America today, a breakdown of electricity is 36% petroleum, 33% natural gas, 13% renewable, 10% coal, and 8% nuclear. In order to justify an electric vehicle's positive effect on the environment, America would have to grow its renewable energy by exponentially in order to go from burning gas in tanks to burning gas in giant plants. But achieving the increase of electricity needed to power a full switch to EVs through the renewable energy sources of wind turbines, hydroelectricity, and solar power would still be detrimental to the environment. Let's start with wind turbines. Wind turbines make up about 29% of renewable energy. They use wind and harness it to create energy. Sounds pretty clean, but there's one major problem. The giant turbines on wind turbines are non-recyclable. They're made from a mix of resin and fiberglass, and other than being a giant turbine blade, they're completely useless. Many landfills are having problems with them because of their immense and awkward size. Presently, they're being chopped into 3 pieces and stuffed inside of each other to conserve the most amount of space possible. These arguably do more harm than good to the overall environment because of the amount of pollution, land pollution instead of air pollution that they cause. The second biggest form of clean energy production is produced by hydroelectricity, which is giant dams built on rivers that use the naturally flowing water to create energy. However, these require an absurd amount of money, time, and labor. And also, they require a natural body of water occurring in a very specific way in order to be able to even be built. Most of these places in America have already been taken, making hydroelectricity an unrealistic source of growth. Also, forget carbon emissions for a second. Hydroelectric dams do actual real-time damage to wildlife and ecosystems that are needed for wildlife to prosper and do actual damage to our environment in real time. The third largest form of energy production through renewable energy sources is solar power at 15%. Solar power has a dark side, however. It is made of many of the same materials as a lithium-ion battery and is completely unrecyclable. By 2050, researchers estimate that there will be 78 million tons of toxic waste caused by solar panels alone, and an additional 6 million every year following. Where will they go, and what will we do with them? With hydroelectricity at a major standstill and wind turbines and solar power doing arguably more harm than good for the environment, it seems that there is not very much hope for renewable energy. But either way, over 87% of electricity is made through unrenewable energy sources, making America going from burning fossil fuels in millions of small tanks to burning fossil fuels in thousands of gigantic plants. After an electric car is built and after it's run the course of its life, what do we do with it? How do we recycle it? Well, the bulk of an electric vehicle is made up through its lithium-ion battery. Internal combustion cars also have batteries. They're called lead-acid batteries, and somewhere between 95 to 99% of these batteries are efficiently recycled. According to a study done by Australia, 98.3% of lithium-ion batteries are thrown away, meaning the same amount of lead-acid batteries that are efficiently recycled is the same amount of lithium-ion batteries that are thrown away. A full switch to electric cars would involve a full switch to lithium-ion batteries, which would involve a full switch to landfill-bound batteries. Landfill space is not the only problem, however. Many landfills are reported that lithium-ion batteries drastically increase the chance of landfill fires. Over 124 fires were reported in one Pacific Northwest landfill between June 2017 and December 2020. Lithium-ion batteries fires are especially hot and violent and have been known to last for up to 10 years at a time. Burning batteries is not what you would think of as the greatest thing for the environment. A lithium-ion battery is essentially a capsule of cobalt, lithium, nickel, and other elements encapsulated into a cell and glued to other cells, which are glued to more cells and more cells and more cells until the battery is complete. The glue used by Tesla and other brands is nearly indestructible. Nevertheless, there are three main types of electric vehicle recycling, called pyrometallurgy, hydrometallurgy, and conventional. But the three recycling options are still harmful to the environment and the people involved. The first way is pyrometallurgy, which involves shredding up a battery and then burning it over and over again at higher and higher temperatures, and then taking out all the unburnt materials from the pile of charred rubble. This has about a 40 to 60% success rate. The amount of emissions caused by burning one battery through this method is actually rivaling that of a diesel truck through its entire life. Chemical fires are not quite what you would think of as great for the environment. Hydrometallurgy is the second form, which involves dipping a battery into an acid soup type substance and then taking out all the unmelted materials at a similarly depressing success rate of 40 to 60%. This acid is then dumped into land, which will never recover from the acid being dumped on it, meaning even more land pollution. Oftentimes, these two methods are combined, making a magical mix of burning and acid melting. Land pollution and air pollution are not the only problems, however. Many health-related concerns are being shown from these two methods, and the European Union has already banned both of these methods, and the US is not far from it. There's a third way, however, called the conventional method. and this involves picking apart the battery piece by piece and taking apart each individual cell and taking out the materials. This, however, can take anywhere from 2 to 24 hours per battery, making it economically infeasible. Many people think that with the right increase in technology or the tweak to these methods, electric vehicle battery recycling is on the horizon. However, it is sadly not true. With ever-changing battery formulas, many of the materials extracted are completely useless or nearly useless, and with the ever-expanding mining of the materials, many of the materials recovered trying to be sold in small scales is like trying to sell dirt. The one material that keeps the business afloat is cobalt, but many companies are trying to exclude cobalt from their battery formulas, essentially dooming the business. With all of this inefficiency, it is no wonder why most battery companies just end up buying cheaper materials and newer materials for lower costs. But this does have a detrimental effect. What we don't want is years and years of buildup of a cell that we can't take apart. It's not happening yet, but with the ever-increasing amount of electric vehicles being produced and with a full switch, this will inevitably happen and be very destructive when it does. Inefficiency, waste, human rights violation, and environmental damage are all realities connected to EV production, use, and recycling. Do we really believe that electric vehicles are any better than internal combustion cars? Do we really believe that they are the answer? Sadly, it is true that still today, the internal combustion engine is the lesser of the two evils. Though not obvious, embracing this new technology embraces the very evils we hoped it would solve. Thank you.